we said differential calculus is basically used to study the rate of change. Is used to study the rate of change of quantities. That's what we said. We said that several quantities exist. Several quantities exist. Depending on what we are looking at, we might want to study how temperature is changing over time. Okay, we might want to study how the population growth. We might want to look at business profits. And loss. These are quantities that can change over time. Today you can make profits of 200,000. Tomorrow you make 130,000. The other day you make 50. The other day you make, like, it is a variable. Okay, this is something that is variable. Okay, as compared to time. So differential calculus comes to examine the change, to quantify, to examine how change in temperature, how change in time affects temperature, or how change in other factors can affect the population growth. Okay, that is what differential calculus entails. All these quantities we are mentioning about here can be expressed in terms of functions. Okay, can be expressed in terms of functions to relate any two quantities. Okay, where a function is basically a relationship between any two, between a set of inputs and permissible set of outputs. Okay, we said that a function can be expressed in terms of fx, in terms of gx, gt, hx, among others. There are many ways of coming up with such functions. Okay, like mentioned above, we can have a quantity of speed, and we want to understand how this quantity that is expressed in form of a function can be changing, okay, can change over time. So if x is a variable representing time, if x is a variable representing time, if x is a variable representing the time, that means as x changes, okay, as x changes, definitely fx also changes. Okay, fx also changes. A good example can be here. If f of x equals x squared, okay, if x is 1, 2, and 3, definitely the values of x will be 1, 4, and 9. We realize that at every point, as x changes, it also triggers the function to change. As x goes to a 4 to a 3, also the function value changes, and the process continues like that. So what differential calculus comes to examine? It comes to examining how best we can express this function here, okay, in a form that leads to this kind of change. That is differential calculus. Yes. Pardon? Others, are you seeing your screen or not?
I am seeing the screen on my side.
Yes, we are seeing your screen.
The screen is okay. Is the screen now okay? Okay. So we have said that as far as differential calculus is concerned, okay, as far as differential calculus is concerned, the quantities are always expressed in the form of function. Okay, so if f of x is a function, then its differential calculus or derivative will be given by f prime x. Okay, if f of x is a function, then its differential calculus or derivative will be given by f prime x. Similarly, if f of x is equivalent to y, then f prime of the function will be the same as dy dx. Okay, the derivative of y, but with respect to x. That's how we can read this. Derivative of y with respect to x. These two things are actually the same. Okay, depending on what has been given. Okay, if you're given if y equals 3x squared, someone can tell you to find dy dx. Also, if f of x is equivalent to 3x squared, someone can tell you to find f prime of x. So it is important that we understand and appreciate this notation. Now, how do we progress? How do we progress from fx f prime? How do we progress from fx to how to progress from fx f here to us? I can pose a few questions here to all of us. How do you find f prime x? That is the first question. The second question, how do you find dy dx? That is the second question. Okay. The third question: how do we find the derivative of a function? How do we find the derivative of a function? Third question. The fourth one and the final one: how do we find the differential calculus of a function? We have four questions before us that are built from this previous slide, which discusses the differential calculus, what it is as a function. Okay, if x, its derivative is f prime x or dy dx. So when you closely look at these questions, four questions, they are actually requiring the same solution. How do you find f prime x? It is the same as the dy, the same as the dy dx. How do you find the differential calculus? How do you find the differential calculus of a function? Okay, I want to answer those questions, all of them at once. I want to answer all those questions at once. They are actually the same questions. They are the same questions. Are you guys there? Are you there?
Yes, we are here.
Okay, thank you very much. Thank you for responding. So, how do you find differential calculus? How do you find f prime x? How do you find dy dx? The answer is finding this is governed by rules. Differential calculus is governed by rules. Number one, let's look at the constant rule. With the constant rule, if f of x is a function that equals to c, where c is a constant, okay, we can always find its differential calculus f prime x as 0. Okay, we need to note that all functions which appear to be a constant, their differential calculus, all derivative, their differential calculus is a 0. I can have an example. E.g., if f of x equals, say, 6, f prime of x definitely is 0. If f of x is equivalent to 1000, still f prime of x equals 0. So what does this mean? I can explain that using geometry. Okay? Consider a graph. Consider this graph where this is the y-axis and this one is the x-axis. Now, once I draw this line, maybe this is a line, maybe this is a line y equals maybe 5, y equals 6. Okay, what do we notice? That over time, this line is going to be a constant, like this. Wherever it is going, it is a straight line, and it is going to be a constant in that direction. Okay, so a significant observation we are making, there is no change in slope. There is no change in slope. Okay, it is a constant. There is no change in slope, and the slope is a constant. Okay, so that means that the rate at which the slope of this graph changes is basically a zero. There is no change. You can always see that it is a straight line and it will flow wherever it is ending, depending on the values on the x-axis. Okay, so but now first see this other small example. If this line was just going like this, and this one is the y-axis, this one is the y-axis, and this one is the x-axis. This is evident that as the coordinates keep getting plotted onto this line, okay, it shows that there is either increase in values for the x-axis and increase for the values increase in the values of the y-axis. So there is change. Okay, we observe change. It is not a constant. So such a function leading to such kind of line will definitely have a derivative. Defining, yes.
I can't see your screen.
Oh, on my end it appears shared. Is everyone not seeing the screen?
It keeps going on and off. I don't know.
Try to refresh, David.
I think it is on. Try to refresh like a channel. Or you guys suggested.
I'm also experiencing the same.
Oh, really? Let me stop sharing and share again. Let me stop sharing and share again. Share, present this. Okay. I'm trying to share again so that you see how it works. This is the Facebook channel. Okay, let me share. The screen is be back. Just to double check. Double check and see. The screen should be there. It should be visible. So I was still mentioning something about the constant rule and saying that the constant rule, whatever is applied, shows that the derivative of a function is actually 0. Okay? Whenever we are talking about a constant function, such as f of x equals c, where c is a constant, we do not need to waste any of our time. We shall just say that f prime is 0. Okay? And we can have as many examples as we want. For example, if f of x equals 5, I have an option apart from saying prime x equals 0. If y equals 10, then we have to get the dy dx, y dx, and it should also be equivalent to 0. So in other words, even if your function has a component, it should be 0. Okay? I hope now we know what a constant is. I want to switch to the next one, which is the most common rule. Rule number 2 is called the power rule. Power
Excuse
rule
me, sir.
applies to functions
Excuse me, sir.
that have higher degrees. Yes, please. I'm listening.
Continue, sir.
Maybe we can
We lost
continue.
him.
If he wants, then he comes back and
Okay. So for the power rule, let's consider a function. If f of x is a function that is given by x power n, where n is a positive integer, then we shall find out that the derivative, which is f of x, is equivalent to n minus 1. This is a very fundamental rule. It's a very fundamental rule, and in case you miss it, then you're going to find differentiation is very complicated because it is the most commonly applied rule. Okay. We talked about different types of functions, including polynomials actually, including algebraic. These functions are very common when we are studying about different quantities, how these different quantities. Okay, so it is important for us to know that once we have the power rule, we can actually differentiate most of these quantities and be able
Excuse me, sir. What is integer?
to hear me. Let me first get
Wow.
yes.
What is an integer? I'm saying what is integer? Integer.
Can someone tell us what an integer is? What is an integer?
A whole number.
A whole number. So, an integer, we must have studied about a number line. A number line looks like this. This is -1, this is -2, this is -3, and so on and so forth on either end. That's what we call a number line. A number line has integers, and integers start from 1, 2, 3, 4, 5, 6, 7 onwards. Those are positive integers. Then
A number
also
with
have
no
negative
decimal.
integers. Exactly, it is a whole number. An integer is a whole number, but now we are only interested in the positives. Okay. For example, if f of x equals to x power 5, you see that n equals 5. Okay, and follow
Hello, sir. We've lost
power
you.
rules. From my network. Is it my network or
It's like it's your network. We're all behind.
I hope this will be a better service provider. I hope this will be a better service provider, and we can push on swiftly. Is my screen visible? Just checking in.
Yeah, it is visible now.
Okay, I have just changed the provider. I hope it's going to be a better connection. Let's push on and see. I was still mentioning about the power rule. So the power and reduce the power by 1. To get the derivative. Okay, find dy dx. Yes, this is another example we can think about. This is another example we can think about and see if it is making any sense. If y equals x power, find dy dx. So you will realize that the dy dx, you realize that we are using the same approach. We shall say that dy dx is actually equaling 4, then x, then power 3. We are not in any way interested in first principles showing us how you have multiplied, how you have subtracted. It's just important for you to master the concept that if I have x power n, to get the derivative, I multiply by the power, okay, and then reduce the power by 1. Once you get this by fingertip, this is what we call the power. This is what we call the power rule. There are many rules. You shall eventually use them in a combination. For example, another example, if you say you're given a function f of x that is equivalent to x power 4 plus 8, you realize that we have a constant here, and we have how do we call this one? And we have we are looking at the power rule example. The example we have, if f of x is equivalent to 2x squared plus 3, okay, into 4x cubed minus 5x squared. Now, Look at such an example. Near identification of products between two functions gives you what method you need to apply. Okay? Comparing to the method we've seen that if f of x equals hx dx, we said f prime x is going to be h prime x times the second function plus the second function prime times the first function. So if we take this one to be something like hx, take this one to be dx, we shall get f prime x to be equivalent derivative of the first function, which is 4x, into the second function, plus derivative of the second function, which is going to be 12x squared minus 10x into the first function. X squared plus 3. This 20x4 x4, right, plus 36x2 minus 20x3 minus 30x. Collecting like terms is going to give us 40x4.
Sir, you're too
40
fast. You're too fast.
X. Okay. You know.
Excuse me, Mr. Chimera.
Yes, please.
It seems like you are taking us very fast.
Okay. Sorry, you
Lower
are not
your speed. You can get to the
No. Okay, no worries, no worries. For this specific example, let's repeat, okay? For this specific example, we can repeat. Okay, comment again. Whenever you feel I'm moving so fast, you slow me down. Okay. Product rule.
Mr. Chimera, you can repeat the whole process. Thank you very much.
It is fine. I'm going to repeat. Don't worry. Let me even go back here and review the product rule. Okay. For the basic rules, we have seen the sum of the different. Now we need to apply those rules to these advanced rules. The first advanced rule we are looking at is called the product rule. The word product in mathematics means multiplication. Correct? Means multiplication. But now that we are looking at functions, this is not the usual multiplication of 2 times 2. We are now multiplying functions. Okay? So, according to this rule, if we consider a function f of x that is a product of 2 functions, okay? A product of 2 functions. If we need to find the derivative of such, the product rule states that first get the derivative of the first function, multiply the second function. Add on the derivative of the second function times the first function. Okay? Does that make sense, guys?
Yes,
So
yeah, we are.
Yeah.
Uh-huh. Just some basic logic here, because this is, even if you're studying a PhD, the productive will remain productive. So let's grab a pattern that I'm looking at. Product rule is multiplication between functions. An example we can have here, x cubed, okay? This is already 1, and this one is function what? 2. This is the function 1, and this one is function what? Function 2. Are you getting me, guys, here? So it is definitely a requirement for you to apply the product rule. Meaning, if this is function 1, we can actually remove this one. If this is function 1, we can maybe call it e of x. And function 2, we call it maybe h of what? Of x. And now to get the derivative of this one, we are going to kind of substitute here. Okay? If this is, if this is gx, let me just use this space. If this is gx, and we are saying gx is x power 3, then we can get e prime x, which is 3x squared, correct?
That is where my
have,
question is, sir. Yes, how do you get 3 power 2?
Were you here from when I started? Sorry to ask that question.
It is 3x square, not 3 power 2.
Can you ask here again? You're saying, how do we get 3x power 2, correct?
Yes, please.
Okay, now guys, by the way, I forgot to emphasize this. The way I teach my mathematics is like this. If you miss a step, you're most likely going to fall. So
Sir, you break.
like we have step 2 to step 3, step 4, like that. Okay?
You're kind of breaking.
So, okay, sorry. I'm saying that the way I'm handling this mathematics, we are like building a house from the foundation upwards, up to the roof peak. So we talked about the power rule. So this is got from the power rule. Oh, this is got from the power rule. My friend missed it. I repeat it, but we talked about the power rule, chief. And the power rule says that if f of x is equivalent to x power n, then to get f prime x, we get n, it multiplies here, then x, then n minus 1. So if my function g of x equals x power 3, check, g prime x is going to be, the power comes here, then x here, and n minus 1. So it will be 3 minus 1, which gives me a what? A 2. So it is not grammar, but it is a principle application of a specific rule. Does that make some sense?
Yes, I thought each rule stands on its own, but it's nice. I get now.
Okay, that's great. So this is something. Pardon?
You've got where it originates from.
This network is very poor.
So you can carry on now.
Okay, let me handle this example from first principles so that we see. Okay, I'm going to attempt it very slowly. Now, we have said that according to the product rule, please note this. If you have two functions, g of x times h of x, then f prime x is going to be g prime of x times h of x plus h prime of x times g of x. Now you realize that here, these are two functions. This can be maybe g of x, and this one can be maybe h of what? Of x. Okay? And on the side, if my g of x equals 2x squared plus 3, you see, I can get my g prime x as 4x. Does that make sense? Is everyone understanding where I'm getting the 4x?
Yes, sir.
Yes, sir.
You've multiplied.
Okay, good. Let me make this one very, not clear. Let me remove, since I'm going to share with you guys. Okay, we are saying g prime is x. Then see, we are saying that let hx be this. So if my h of x is 4x cubed minus 5x squared, then I can still get h prime x to be 12 of x squared minus 10. Are we guys together up to that level?
Yes,
Yes,
sir.
sir. Yes, sir.
We are together.
Okay, good. Now, if we want to substitute here to get f prime x, we are going to get d prime x, which we have already got as 4x, times hx, which is 4x3 minus 10. Sorry, not 10. Minus 5x2 plus h prime x, which is 12 x2 minus 10x into dx, which is 2x2 plus 3. We need to expand this and simplify, giving me 16x power 4 minus 20x3 plus 24x4 plus 36x2 minus 20x3 minus 30x. So I have it just expanded, multiplying out of the bracket. Is that step clear? I have just multiplied out.
Yes, yes, yes. It's very clear.
Excuse me, Mr. Chimera.
Yes, you.
I wanted to know where do you get
Work
where you get 20
from your microphone, please. Get closer.
Mr. Chimera.
Prefer from it. This one. Yes.
Mr.
I've
Chimera, I
got
wanted
you.
to
I
know
think
where
you're
you
talking
get
about this 24, correct?
Yes, yes,
This one.
yes.
Yes, check. How do you multiply out these brackets? These ones.
You just multiply 2 times 2 to get 24.
Everything in the first bracket must multiply everything in the second bracket. So this one becomes 12x squared times 2x squared, getting us 24x power 4. 12x squared times 2x squared. This one gives me 24x power 4. So this is algebra. Amon,
Yes, sir.
have you got the 24 now? Are you the one who was asking?
Yes, Mr. Chimera, I'm getting you.
Can I proceed?
You can move on.
Okay. Okay. No worries. I'm about to end my class. I don't want people short circuiting. Yeah? You know short circuiting? When a wire.
Sammy, are you there? Sammy, Samuel, are you there? Answer the remark.
Sir, let's go
We
after
are about
8:30.
wait. What are you talking about?
I don't, hey,
You want to suffocate?
I don't want people. I don't want to collect like terms. Collecting like terms will make me get 40x power 4 minus 40x power 3 plus 36x power 2 minus 30x. And that will be the expected answer for fx prime. Now, allow me to touch one concept. Briefly, I'll repeat it tomorrow. I want to touch one other rule. Okay, I'm giving only this one example. I have some exercise for you down there. Yes.
Actually, I'm not. Where have you got a 40? So, because I'm not getting it here. I'm not seeing it.
Yeah, even
Where have I got what?
Which
Yeah,
which
where do
40 which 40 x power 4 or 40 x power 3?
For any 40.
Okay.
Actually, all of
How
them.
have we got this one? How have we got this one? You have 16. You have 16. Let me use black. We are collecting like terms. Okay, maybe people wanted me to
16 plus 24.
collecting like terms together. For example, if you have 16x power 4 and 24x power 4, this one will give us here, go to the second 40. The second 40. The problem is what?
I've understood it.
Your vocal is distorted.
I've got now.
Really, Bane, people stop over blaming my network. Some people, it is your network. But now everyone is blaming mine.
But you continue, sir. Musaja is okay now. Has already understood.
But don't worry, I'm going to share this with you, okay?
I've already understood, but sincerely speaking, Mr. Your network today is very poor. That is it for sure.
But guys, I think I need to. Okay, now let me do this one. Numbers given, quotient rule. Open your eyes a little wide. Quotient means division. Okay, and if f of x is equivalent to p of x over h of x, you see that? That is division. Are we together? An example you can think about, e.g., if my f of x was 3x squared over x cubed minus plus 2x. You see, this kind of setup, it is a division. Are we together?
Yes, we are together, sir.
For such cases, I said open your eyes a little wide, but not very, very wide. Okay? Just slightly wide. It is
Yes,
going
sir.
to be the derivative of the first function times the second function minus derivative of the second function times the first function all over divided by hx all over divided by the second function squared. That is what we call the quotient rule. Let's complete that example. Let's complete that example. It has been f of x equals, what is it? 3x squared over, what is it? X cubed plus 2x. X cubed plus 2x. You see this? Here, let's make this guy to be dx. Let's make this guy to be h of x. Okay? For purposes of reference, f of x, we said equals the first one prime times the second one minus the second one times the first one all over divided by the first one squared. Okay? And now on a side note here, if my first one, which is dx, is x, is 3x squared, then d prime x is 6x. If my h of x is x cubed plus 2x, then my h prime x is sitting here. My f of x is going to be d prime x, which is 6x, into x cubed plus 2x minus h prime x, which is 3x squared plus 2, into dx, which is 3x squared, all over divided by x cubed plus 2x squared. We can try to expand and simplify. Expand and simplify. And whatever we come up with will be making a lot of sense. What we are supposed to get. So I realize you guys need to revise your algebra. I'm not moving so fast, but I'm just doing the best things maybe very fast. Now. Okay, here, copy this, let me see. Now guys, when you check the notes, this is not the answer, simplify. Let me just leave a note. Multiply to brackets and brackets and so down here you'll find the notes. I don't think I need to go through reading this. It bores me a lot. I start reading for you, finding a derivative, blah blah blah. Everything I've touched is here. I know power rule. There is an example there. Some difference, constant multiple. Try these questions. Product rule. Example. Check out this one. Okay, maybe I didn't want this one. Okay, it's fine. Down here, product rule, okay, quotient rule, okay. Here is an example, and this one, best maybe. Okay, So we have something on slide. Which slide is this? Slide 49 and 50. Let me add another one here. And in that other one, okay, in this other one, I want you to put a note. You are required to practice with questions on slide 50 and 51. We shall review them in our class. We're talking about slide 51 is here. So I'm saving this one. File, save. Let me share it on WhatsApp. Okay?
So first go back on
But
the
can
previous
someone
slide. Let's go back on the previous slide.
the previous slide? Okay, it's
Yes.
fine. I'll go back. Oh, it is still saving. I have written there a little things. It's still saving, so no worry. Just give it a few minutes. So guys, I'm just planning to close. I think I'm exhausted like you guys are. And whatever we've touched is enough for today. Pardon?
Are you going to leave here tomorrow? Oh, we have ended today for this week.
No, even tomorrow, my flight will be at night.
There is a lecture tomorrow.
Mr. Chimela, I have a
tomorrow we have a class. You're already tired of me?
No, we are not. Mr. Samuel.
But sir, you first finish the other question on quotient rule. Some of us are getting wrong answers here.
How? You don't know how to simplify. Where is it? Where is it? Where is it? Maybe. One? Chief, which question do you want me to repeat?
This one.
Mm-hmm.
The one
What's
on
wrong?
the screen.
You want me to simplify it for you?
Yes. Yeah, I'm getting -3 x power 4 plus 18x square all over x cubed plus 2x all in square. So you first help us so that we are confident of whatever we are doing.
It's fine. I can complete it. No worries. But I'm not going
to... If you could take on this question as well. Is it okay? Okay.
Okay, it is okay. Let me first finish this one. You're the last one to submit.
Okay.
Okay, so here, this is going to be a 6x power 4 plus 12x squared minus 9x power 4 minus 6x squared over x power 3 plus 2x squared. Here, the upper one becomes 6x squared minus 3x power over x over x sure good plus getting, but this one can actually can be reduced further. Is someone seeing how it can reduce? This one, if I wanted it to the simplest form, then that one would not be the final answer. The final answer will be this. On the above, I can put x squared outside. Does everyone see that?
Yes.
Also down, can everyone see? Can
X
everyone see
square.
this outside?
Yes. X plus 2. Okay. You cancel x squares.
Mm-hmm. And then you remain with the rest.
Okay, thank you.
Because someone can tell you to apply the quotient rule and present the answer to its simplest form. That means if the question has 5, you can grab a 3 or a 4 if you stop here. Guys, I can't teach for the 3 hours, so you will have to excuse me. Let me just share with you these materials for your personal kind of reader, for your personal consumption. Okay, but now there are many mathematical groups here. Can someone help me identify the correct one if we have a coordinator? Like there are many. I think every class is creating a group and adding me.
I think Alpha will pass sir.
Yeah, Alpha and Monica. They are going to
Alpha, Elifa, Alpha.
we have to have a man and a woman. So we have
Yeah.
actually Alpha is even on the side of this, we have to get Monica. So actually,
On the Alpha, identify yourself, man. You are there hiding.
Okelo can also help.
No,
So
Alpha.
someone can help me identify which is the correct group by maybe texting something. Jirabe, I put the notes. This one,
Alpha,
my right
identify
up.
yourself. It's going to inbox you, sir.
It is fine. I'm also saving this file so that I can get it to you guys for your personal check, for your personal checking. I think it might be a little helpful. Though my write-up is not so organized, but it is okay. It can be helpful to add to the notes you already have.
Mr. Chimela, I had a quick question.
Please ask. Sorry, I had forgotten.
Okay. Now, when you go to the slide where we have questions to practice, I've seen today we've touched different rules altogether. But as I saw the question, not specific to the rules we are going to relate to when we are giving, when we are practicing as well. I wanted to give a clarification in that.
No one is going to tell you that you use this rule or this one. You supposed to use Sable. I'm opening it again so that I share it, so that I will look at them. We have seen the quotient rule. So, the file is heavy. I hope it will go on WhatsApp. Looks heavy.
Mr. Chimela, I didn't get that feedback properly. You were skipping.
No worries, I'm sharing. I said
About the questions.
It is okay. I'm sharing it here so that
Okay.
we are looking at it together. Just give me a second. I'm pulling out the document. Just funny. It is if it is taking much time to open, as if I'm using a Pentium 2 computer. Sorry, I'm opening a file for sharing here. Okay, it is happening. Need to please. Okay. Yeah, how is it this one? Yeah. Okay. So now when you look at the questions, are you there?
Sure.
Yes, you need to know which rule best applies and use it. But no one will tell you that use the product rule, use the quotient rule. No one. Okay.
Yeah, understood.
Okay. So guys, why don't you allow me close the class?
It's okay. It's okay. You are allowed.
Okay. So now the challenge is sharing this file. I just don't want to send it to a wrong group.
Sir.
Yes. So how are you guys getting this file? I don't know.
We have written to the group that you want to share the materials with. Just go to your WhatsApp and see.
Hey, Kali. You know, I don't want to disconnect before I send. I might get mixed up. So where is the thing? The file is here. Where is it? This is bad. I see it. Okay, here is the file. Sure. This. Do we have girls? Do we have ladies in class?
Yes, they are here.
I have. Not saying anything. Okay, so here is the file. My friend is saying. Oh, this one with the math one. This is the group that posted here. Okay. Let me drop this file here. Good. You should have it. I have dropped the pin there.
It is well received. Thank you, sir, for sharing.
Guys, I'm logging out. Good night.
Good night, guys. We meet again tomorrow.
Yes.
Mr. Okello. We'll meet tomorrow again. Samuel, Edward, guys, try again
Sammy, are you
tomorrow.
Where are you going?
Benje.
Are you
Man,
feeling the heat of
How are you, man?
Okay. Are you feeling the heat from Mars?
Why are you keeping quiet?
Guys, hello. I want to pass something.
Guys, have you picked up something?
Uh-huh.
Yeah, we have proof
I'm of the view. Eh?
Eh?
I'm of the view.